Honorable Principal Dr. Sanjay Bokade, Head of the Department of Instrumentation Dr. S.P. Sadala, ISA RJIT Faculty Advisor Professor Dipali Joshi Jain, all the teaching and non-teaching staff, students, and participants present here on this virtual dais. I, Shri Sogli, on behalf of MCT Rajiv Gandhi Institute of Technology, Department of Instrumentation, welcome you all in this Alumni Speak series. The purpose of this series is to guide the current students to make a qualitative analysis of their respective field, interact with our experts, and carve their own path to a successful career. Before introducing to our today's speaker, I would request our Honorable Principal Dr. Sanjay Bokade to say a few words on this occasion.
Thank you. I hope I'm audible to all of you. And
yes, sir. You're audible.
yeah. And Saylee is our guest today, or alumni. So I'm very happy to know that our alumni in our Alumni Speak series in continuation. I think this is the third Speak series event by Instrumentation Engineering Department. And today Saylee is with us from 2008 batch. That is great. And one of the most promising topics will be spoken by her. And the topic is industrial IoT and 3D printing. So something of very high importance is this topic. When we were these days discussing on industry 4.0. So the key term, the technologies, the driving technologies of industry 4.0 is IoT and 3D printing. 3D printing is these days the newer version of manufacturing. You otherwise have additive manufacturing, subtractive manufacturing, and you remove the unwanted material and make the jobs the way you want. Now, by 3D printing, you almost you can print anything the way, if you can make an image of it, you can print that thing. And the finest of the accuracy and finest of the tolerances can be obtained through it. And something which is absolutely impossible to be manufactured by the traditional methods can be very nicely 3D printed. And that is what is the most upcoming technology, which each one of us must be aware about. And it assures you about a good prospects in the industry also. If you tomorrow say that you are you have got good expertise in 3D printing, and then IoT is IoT, because tomorrow it is all the life, the industry, the life, or everything. This will all run, which will be for which the fuel will be IoT. What is in my mind. So that is great to see you all. I think I welcome all the participants who joined us in this Zoom room, as well as all those who are with us on the YouTube streaming. So thank you so much. Over to you.
Thank you, sir. Thank you, Principal, sir, for addressing our participants. Today, in this Alumni Speak series, I take this opportunity to present before you our third speaker, Ms. Saylee Panchbhai. Saylee ma'am completed her BE in Instrumentation Engineering from Rajiv Gandhi Institute of Technology in 2008. She has completed her MS degree from the Kalyan College of Engineering at University of Houston. Saylee ma'am has 3 patents in her credit. The first patent is on systems and methods for identifying end stops in linear motor. The second patent is on systems and methods for detecting pump-off conditions and controlling a motor to prevent fluid pound. And the third patent is on systems and methods for determining forces on a linear permanent magnet motor using instantaneous current vectors. In addition to these achievements, she has been awarded the Building on Diversity Women's Resource Group at Baker Hughes Incorporated. She has also been a recipient for the Engineer in Training Houston, Texas certification by the NCEES Board of Professional Engineers. She is currently working as a control system specialist, aeroderivative gas turbines at Siemens Energy in Canada. After knowing about their amazing achievements, now it's time to hear from the speaker herself. Saylee ma'am, over to you.
Thank you, Shirish. Can you guys hear me?
Yes, ma'am.
Yes, ma'am.
Yes, good. So thank you everyone for inviting me to this alumnus speaker series. I am very excited to be here, be back in RGIT somewhat virtually. But firstly, I hope everybody back there in India or whoever's listening on YouTube, they are fine with the COVID scenario. The first message that I would like to give everybody is stay safe, wash your hands, and wear your mask, wear your gloves wherever you go. So that's my little safety moment. And like I said, I am very excited to share this topic with you guys because this does not directly relate to what I currently do at Siemens, but it has been in the past my interest, and 3D printing currently I do as a passion at home. So whatever knowledge I have gained through my projects in my previous companies and indirectly working with control systems now, it's all of IIoT is all a part of the activities that we are going to do in the near future. And like Mr. Bokade said, it is Industry 4.0. This is 2020, and we are in Industry 4.0 moving to the next step. So it is very important that all you guys realize like where we are today and what your education is going to take you to the next step. So in today's webinar series, I'm going to talk a little bit about myself. I'm sure you guys heard my introduction, but I would like to share some experiences along the way. Then I would like to touch on the industrial IoT, the basics of IIoT, what it is, what are we going to use it for, Industry 4.0, like I said, and then we'll dive directly into a real world example because without knowing how it applies to our everyday lives, we really are not going to learn anything. It's just like, oh, it's in the book. Maybe it just stops there. It doesn't have any real world application. So we're going to look at that. We're also going to look at what the next path is. What are we looking at for in the next couple years? Now that there's a COVID scenario, things are going to change very rapidly, and it's going to affect how we look at the next industry, what's going to come after 4.0. After that, I'll talk a little bit about 3D printing or additive manufacturing, like it's called, and then I'll open it up for Q&A. I would really like to see some questions from you guys and make this session as much interactive as possible, so you can learn more from this series um, for which you guys are here. So that's me out in the oil field. Like you've seen, the sectors that I've worked on are energy, digital marine, and oil and gas. And mostly all throughout these sectors, I have tried to look at what I really like to do most. What I'm best at is control systems. When I left RGIT in 2008, I knew I knew my basics, but I didn't know the real world applications of control systems. We learn everything about PNIDs, process control, and valves, and we had electives for robotics, and it's there. Like the knowledge is there in the head, but what do we do when we go out there? Like how is it really implemented? So when I went to my first job, it was a control systems job, and I was like, okay, I have seen all these things like in the book, but I don't really know how these interact with each other because we had not done internships as well. And I'm really happy to see that you guys are doing internships now. Like it's been 12 years. I'm sure there's been like a whole leap, like learning, steep learning curve for everyone, and for the universities, for the colleges, for the students. And it's great that you guys are doing that. But I'm going to like go in a reverse chronological order. So right now I'm here as a control systems specialist with Siemens Energy. Our main product is aeroderivative gas turbines. It's like an industrial aero engine. Basically, it was a Rolls-Royce division, which then was bought by Siemens Energy. So it's quite an experience to work with an engine control system. It's still applied to energy, but it has got an aero background. So it gives like a full aero mindset of developing an engine control system. So this is where I am for 1 year, and I'm really enjoying it. Um, Before this, I worked all my 6 or 7 years in the US. GE Energy was my previous company, also doing power conversion systems. I got to actually work with the GE Predix system, which is an IIoT system there for digital marine systems. And that is where I gained that like that knowledge and that excitement of, oh, what is really like IIoT? What are they doing with it? Where is it heading? And it was quite a neat experience of implementing um, uh, IIoT communications for an offshore vessel. So that's why it was a digital marine project going offshore, off the shore of like Norway. So I had that experience to work with them. I also worked on some solar and LNG projects. I got the opportunity to go visit LNG power plants and how they had like how they interact, different systems interact with each other to actually get a whole commissioning pass through. Then my first job was R&D controls engineering, which gave me the most exposure, and that's that picture from. Where we had that vial of oil was the first one taken out of a new system that we had developed to get oil from a linear permanent magnet motor down hole. So our product line was variable speed drives, and I'm sure with instrumentation background electrical, you know what variable frequency drives or variable speed drives are, and that really um, that experience gave me a whole lot of, what is instrumentation, what is processes, what the valves look like, how are we scheduling the FMVs and whatnot. So it was quite some experience. And to get all that experience, yes, you heard I got my master's from University of Houston and my bachelor's from RGIT. So, getting in, what really is IIoT? It's IoT like you see on your phones or like your Amazon Assistant, Google Assistant, all of that applied to industries or manufacturing. This term was coined way back in 2011 by the World Economic Forum. And in 2013, Germany gave it a new name. It called it Smart Factory. So initially, people thought it only applied to manufacturing, but no, it applies to pretty much every uh, piece of equipment in industry that can be controlled or that can be looked into. Like for example, when I was working on my digital marine project, I learned that there are these sensors like pressure sensors and transducers that Rolls-Royce makes, which does have condition-based monitoring, like CBM, already embedded in it. And this technology has been there for a long time. So it's quite amazing to see that technology has been out there, and now we are building onto it. So, what are the industrial applications of IoT? Like I said, it's not just industries. It's not just manufacturing. It's everything industrial, like smart grids, power systems, your communications. Every smart cities and smart cars are still yet to come, but we are heading in that direction for sure. So, like I said, the advantages of IoT are that it allows you to reduce cost because you have more uptime. You can see your device, connected devices, and you can determine like what really um, is the efficiency, or what is its runtime, what's the equipment lifetime, where are we heading. So you can take necessary actions based on it. Also, the supply chain is quite transparent. So going from buying from like an OEM or a vendor all the way to making that product and delivering that product, the whole process can be quite transparent in terms of integration with SAP systems, which we generally use for resource planning and all your paychecks and everything for materials, cost, all of that. Then there is ERP systems, which are enterprise resource planning systems. And then there's MES system, which is like a manufacturing based system. So integration with all of that. IoT can integrate with all of these systems, not just the sensors and PLCs and everything. And then it can give you all these advantages of higher productivity, more safety with a whole integrated environment. So how do we really achieve this? Let's just see like where we are in 2020 with that. Like we've heard before, Industry 4.0. We are here, and what are we doing with that technology? So we know there's automation. We can control everything automatically, but how far can we control it automatically? Are we as humans really coming in, stepping in and doing what's required for it to do? Not yet. We are not doing that. So right now it's only machine to machine communication. And when that communication comes in, we get a whole bunch of data. What do we do with that data? We run analytics with it. Either we run it on the device level itself, like you are out in the field and you do it, do the analytics. It's called edge analytics or edge computing, right at the device level, or you take it all the way to the cloud, like your Amazon web servers or different servers where you do the computing, do the analytics, and then you bring back the data to the system or the valve. So that kind of analytics is called predictive decision making. So you can run predictive operations or predictive maintenance. Now this is where, like when I said supply chain is transparent, this is where the analytics comes in, where you have integrated into different systems like SAP and ERP. So you know, okay, let's see, I have an engine that's has a life of 25,000 running hours, and I'm hitting 20,000 hours. I'm going to schedule a maintenance in the next 3 months. You know, you can look at that and see what your parameters are, what your different running challenges are, and then you can say, okay, in the next 3 months, I need a maintenance scheduling appointment. I'm going to tap into my SAP system and tell this person who's my third party vendor to go and look at my engine at this location after 3 months. So you have already scheduled your maintenance for your engine that's running, whose parameters are being monitored either on the edge or in the cloud. So this whole environment is happening today. Like as of 2018, like I know, like personally, I worked on that project, so I know it's happening today. But there are more things to this industry 4.0. Before we get to the next level, I want to go through, take a step back and go through what the whole technology around it is, and how we as engineers, or how our education is really going to allow us to get there. So the technologies that IIoT typically works with, and I might have missed a couple over here. I'm sure you, like after you have all this presentation, you can go out and definitely like look at this information. But this is just like a baseline. So you have these IoT platforms, like I said, like AWS. You have Arduino boards. You have Raspberry Pi. And I personally use a Raspberry Pi. I mean, I literally have a Pi in my home to monitor my 3D printer. I mean, I don't need to monitor because I don't have 2, 3 printers, but I just wanted to play with it a little bit. So what does it offer and all? So I did that little experiment, and it has a lot to offer. Like once you start getting into something, and you're like curious about something, that's the key. Like curiosity is the key. You just like keep digging deeper and you learn a lot of stuff. So coming back, there are smart sensors. Like I mentioned before, Rolls-Royce pressure sensors, they have condition-based monitoring. You have engine health monitoring. Currently, I'm working on an engine control system, and we have a separate cloud edge device that taps into the ECS, and it talks to the world outside. So they take those signals and they look at what's happening, what data can we analyze. Like, okay, let's look at the pressure, like let's look at the temperature at these different locations. How is it opening? Is it closing properly, and whatnot? Then you have PLCs, of course, Allen Bradley, Siemens PLCs. They allow you to look at information. Then there is IIoT protocols. These are also things that I'm sure people in IT and EXTC are maybe aware of, like OPC. It's an open protocol for data communications. There's the MQTT that you use uh, with embedded systems as well. SCADA systems, MES systems. These are all communications protocols without which you really cannot achieve the IIoT process. Of course, there's big data analytics. There's augmented reality, which we all know. If you guys are gamers, you know the AR more. But AR is also used in IIoT, because when you are manufacturing something, and if you have AR capability on your manufacturing floor, you can actually you don't need to go refer like a million manuals to see which screw, which nut goes where. It's right in front of you in your AR, and you can just click and tap on things while you are working on building that product. So it's quite useful. There are some good YouTube videos as well that you can look at. For BMW, I think already uses AR. Um, the cybersecurity, very very important when it comes to industrial devices, especially industrial devices. Like, think about a whole power distribution grid, and uh, you are trying to monitor something on the grid, and the hackers get in and the grid blacks out. It's the blackouts are something that people in the power industry, they really try to avoid it. I mean, that's one of the biggest concerns of blackouts. It's people hacking into the system. So hence the utility industry is a little bit farther away to accept the IIoT as is currently. So it's like the farthest to apply, and more far from that is the oil and gas, based on the cultural mindset. Of course, there's robotics, there's additive manufacturing, and model based computing. This is a very like neat field. I really like, my personal opinion about digital twin is it's quite elevated in terms of analyzing, knowing what your product, system, or equipment is doing. And for that, you need systems understanding. You need model based understanding. It's not just one field of engineering. If any of you guys really want to look into that, it's you need to have a whole set of um, different engineering fields, like curiosity for different engineering divisions interaction with each other. And like I said, all these technologies, even without one, IIoT cannot perform. It's like you, from one end of grabbing the data to the end of doing the analytics, like you, this whole spectrum is required. And what are all these derived from? Really, like all these are just like a subset of the core. Like I was speaking earlier, it's important that you know your basics first. Without knowing your basics, you're really not going anywhere. And what will really happen is you'll have to struggle later in life. If you don't work now, you'll have to work later. So you'll have to work sometime. So you decide what's your choice of working, now or later. So I think I've given quite a few examples of how this whole process works, but here's a little architecture that will clear the whole process in your head. Like I was saying, you look at IoT Edge. There's IoT devices right here. I don't know if I can go with a pointer. Can you guys see my mouse?
Yes, ma'am.
Yes, ma'am.
Yes. Yes. Okay. So let's dive into one example about power systems. So here is your IoT edge device. Okay, so you are trying to get data from the transmission system, from the distribution, from all the switch gear that's on the site. So this data, the edge data, is coming from the site. So what you can do is you can have your servers installed near the site in a way where you are only getting the data and pushing it all the way to this final this cloud right here, the serving storage. And then you are doing your analytics, and then you're pushing data back into the server on the edge or on the site. Or, like I said, in the edge analytics, you could have like a huge server right at the edge. Huge, I don't mean huge means like full room full of server. It could be like a full rack that could take care of the number of devices that you are controlling. And then you can set up the server, very powerful capacity to run analytics on it. And then those analytics, though that data, even though it's the edge data, it does go back to the cloud, and it feeds into the digital twin or the model if you have any, or it feeds directly into regular predictive analytics or anything that action oriented model. It doesn't have to be a digital twin. So that is what happens. So the whole path is from the edge to here. And then there is the customer says, I want to look at maybe like voltage or current or torque on my application, at certain points. I want this rate. I want to see it in a fancy way. Then you do all the development of your HMI, and you integrate with that. And that's where those parameters of those protocols of the OPC communications come in. um, and actually the OPC communications or MQTT or SCADA communications go from left to right, from the edge to the end. But this is the general process of going from grabbing your data from your sensors all the way to delivering to the customer, reducing your cost, increasing efficiency. You increase your uptime. So the uptime is maximized. How much more can you produce? How much more can you give? How cost effective is your solution? What is your value added to the full process of IIoT? Because one of the challenges also in IIoT is legacy devices. Some devices don't have smart sensors. They have just regular sensors. Part of your plant has regular sensors. Part of your plant has smart sensors. So what are you going to do? So the client comes in and they're like, okay, let's just try to upgrade a part of it that has smart sensors. Let's go through a phase one of the project where we try to see what works better for us. Does it work better to do the analytics at the edge, or do we take it to the cloud? How we look at the application, how much value it's giving us. And then if they are satisfied, then they go into the second phase where, okay, now I have these legacy equipments running for 25 years, nothing's wrong with them. But now the company has decided, I want to digitize my whole system. So now I'm going to go and tap into those sensors and change those sensors and make my whole system digital. So in a way, it's like a digitization of the whole plant, but that's up to the client, that's up to the personnel, how much you can you want to implement. And that is one advantage of IoT, is flexibility, is more agility to the process, is it's customizable. uh, how much ever you want to try, like, you can start with something and then you can maybe blow it up or make the whole plant digitized, something like that. One thing I want to add here is, when it comes to controlling your valves or controlling based on some parameter like pressure or speed, if you want your device to act really fast, which some react very fast, which sometimes is the case, when you take the reading, you have to like immediately give it the output. You need edge analytics for it. And I'm not just talking about like what we do today is like we take a speed feedback and put it in a PI controller and it does its job. There are PID controllers in the control systems. There are PI controllers in the control system that do what they're supposed to do with the feedback. But by just learning the activity, um, it's uh, they want to control it more efficiently such that there are less downtimes, there are less mean time before failures, and there are less forced outages. So you want those analytics, you want that data, you want to crunch the data, you want to work with the data, and that's how you will that's why you want edge analytics on the site. That is one decision that customers are really taking seriously, is having edge analytics on the side. So we can have one rack of server, and we can be okay with controlling a lot of devices on this side of the ship, and then have another server on the other side of the ship, and kind of get that area covered, and then all of them are talking over OPC protocol. This OPC protocol, like all these standards of communications are there, but they still need to be refined for IIoT. And that's where I think we're going to go next and see what's going to come next after this. What are these little challenges that I just mentioned, like going to? It is Industry 5.0. And when are we going to get to Industry 5.0? It's already work in progress. We are slowly getting to 5.0. So what is this 5.0 going to do? It is definitely going to solve the challenges of the 4.0, which one of the biggest challenges is device security. You don't want hackers to come in and try to grab part of your system or your entire system, and disrupt the whole like dependency on the system. Like for example, in oil and gas, it's the common sentiment is to not have downtime at all. If they really wished, they really would not have any downtime. But unfortunately, that's not the reality. It does happen. And I know millions of dollars are on the line. Like when you are counting barrels of oil and millions of dollars, it's like the pressure is really high in oil and gas. So device security becomes of utmost importance, and the standards are in place, but they are not completely defined yet. Every country, every industry has different standards that they are trying to adhere to, and that is one work that's ongoing in different industries. For example, automotive, um, uh, aerospace, like these industries are really trying to nail down the standards first. The second thing is replacing all the legacy equipment. Like I mentioned previously, there are quite a few automated systems that are not smart. So those need to be replaced. There is lack of standardization, like I covered, and then skilled workers. People think when automation came, people thought, oh my god, it's going to take all my job. And then when the robots came, like again, oh, everything's going to go, I'm not going to have a job anymore. With IIoT, I'm sure there are these questions in people's mind, and it is going to happen. But it is not that the jobs are going to go. It's just a different set of skill is required to furnish that piece of job. So there is by 2024 there's an estimation that about 150 million jobs will be added with a different skill set, not the one that we are used to working now. But 75 million jobs are also going to go. But if you look at the net worth, we are gaining. We are gaining in the amounts of jobs that are going to be there. But these are just numbers people put out there based on a lot of assumptions. And I do like to read the numbers, but I don't rely on the numbers. So it is important to look at what it has to offer, what IoT has to offer, and you need to tune your skills or hone your skills based on that. It's not that, okay, I did instrumentation or I did electrical and that's what I'm going to do for the rest of my life. uh, that is not the reality. That is really not the implementation or the application of real world. Also, there is data integrity. Data comes in, you need to protect the data. I think today, like with IoT, we are doing a decent job, but we could definitely get better at data integrity. So, like I said, the goal by 2020 is also to have more than a trillion devices on the network. So, industry trillion devices, not consumer trillion devices. uh, what 5.0 really offers is the human machine interaction, not like humans can only do this and machines can only do this. This is your border and you cannot cross. That's not how it's going to be. And what's going to integrate that is machine learning and AI on the edge. So it's going to happen in real time and it's going to be done um, pretty quickly along with humans. So currently there are these projects that huge companies have taken on to develop these cobots, like these collaborative robots. We know we have seen those robotic arms in manufacturing that come in and they take they take any piece of equipment and they do their job and they're done. And we just like kind of have to give them instructions and stand in the front. That's not going to be the case. So now this robot has to learn. It has some of these cobots now have proximity sensors where they sense you coming in, going out. What are you trying to do? Are you asking them to stop? Or it's basically like, like in cartoon style, we've seen Jetsons, right? So it's going to really be like that. You're going to have to interact with the robot and you're going to tell them that, okay, stop right here, let me like fix one more nut and bolt for you, like let me align it, and then now you continue to do it. So it's going to be a collaborative effort. And that's going to be quite exciting to see. One example I want to give you guys about that is I have a little like vacuum cleaner at home. That's a bot. It does its own thing. And when I go and stand in front of it, it just stops, like, or it moves in the other direction and it goes. That's kind of the thing that you need to imagine when you look at a manufacturing site or when you go commissioning out to the field, where I think these things would be very, very helpful, because commissioning of any plants, I mean, it can be a very stressful and a difficult scenario. So having those bots on site trying to fix things or get things made would be very exciting. They could, in the jewelry industry right now, they are using these cobots as a trial, like a beta version, to put little like gemstones in very intricate jewelry, like part of the work, and then like there's someone trying to like fix the length of it. And so they're trying to like see how it can affect these different industries, not just like automotive or oil and gas or power. No, it's going to apply to each and every field of it. So to summarize everything for 5.0 and like difference between 4.0 and 5.0, we are going to have a different kind of skill set. So the labor is going to be different, where humans are going to interact with machines. It's not going to be like a border. And then there are systems that are going to analyze the data, talking to each other. Machine learning is going to happen. There's a lot of model-based learning that's also going to happen. The products and services that come out of all this is going to be personalized. So the market analysis that happens before delivering a product can be can be based on a lot of assumptions. So by the time you get to market, sometimes when you're done designing, there's like no need for the product. So then what do, right? So I think 5.0 is going to close that gap between what the market really wants and what you are going to deliver. Then there is definitely supply chain. It is transparent with 4.0, but it's going to be more responsive. and based in like small pockets, so they can take their own decision. Um, then there's of course like customer user experience. There's going to be things that you need, you can have at like the thought of it. Like you can say, I want this, you request it from your screen, and probably somebody in your site remotely is taking care of it. So those things are going to be in the 5.0 version of it. By 2030, I think we should see a different kind of world. 3D printing. I for this 3D printing or additive manufacturing, I want to mention what was stated earlier. It's like its name suggests, it is additive. So each layer is added on top of the other. Versus subtractive, which is CNC example, or formative, which is injection molding, which involves a lot of losses, a lot of tooling, which is expensive. You won't believe, like if I had to uh, get a metal part that is like, let's say this dimension, and it's a special part, it's a custom part. If I go to a vendor and I say I want this done, they'll say for the tooling we'll charge you 50,000, because tooling is what, like it's a one time job. You make the die and you keep it. Every time you change a little angle in the design, you have to bring another, like you have to make another tool for it. So you keep paying that premium on the tool. So you see, like it's like already very expensive to tool. What additive manufacturing it does is, it doesn't it's not based on tools. It's not based on molding it in a certain way. It just takes your little like model, and it goes layer by layer, layer by layer, and your model is complete. So to summarize that, it's just like three simple steps. You have your model, 3D model, either it's a CAD model or any model. You check if there are any like discrepancies in your model. You try to fill it with a mesh. You send, now that model is in a different format. Now you need to translate it into a printer format or a slicing format. So then there are slicers available where you can push your 3D model through and get out a printer understandable language, which is G code. Generally, that's the language, except if there are like a few ones that work differently for metal or resin, etc. But you send that through a slicer. You say, okay, keep going at this level, at this speed, at this height, at this thickness, and you're done. And that's your final product coming out of the printer. That's a photo of my printer. I know it's a little ugly because I was doing all, like I was trying to get it stick to the base, but that's one of the things that I have printed from my printer. Yeah, like I said, it is less cost, definitely, because you avoid the cost of tooling. When you have to make a prototype, it's very fast. Like you think about something and you draw it on a piece of paper. It's a 2D model. You click a picture, you pass it through a transforming a JPEG to a model file, and you push it through a slicer and you give it to your printer. So basically, you can bring anything to reality, and it's easy. Like then you look at it and you say, okay, the size is not correct. Maybe I need to like increase the width or the height or everything, the fill in it, how thick I feel like. I'm going to give it another shot and see how it comes out, and you can keep working on it. So it's like taking rapid prototyping at like to a new level. There's a quick turnaround time for that as well. Also, it's quite helpful to manufacture complex parts. Some of these parts have, like recently I saw a part being produced at my company, and it had a lot of little like grooves and fixes, and it had like small parts and components and everything. When they used to do it injection molded, they had to do everything separately and then fuse them together. It's all metal. So now we have a metal 3D printer somewhere in Finspong, and they try to do this additively. And it turned out so well without the need to have so many different components and processes in between involved to like fuse them, or tooling, extra cost, paperwork, where you tell the vendor like, okay, I need this, I need a change in order, this is a supply chain thing, now it'll go through too many processes, and just like there are no delays, and you can decide and you can print pretty quickly. Then one of the things that 3D printing also offers is a huge range of materials. There are composites. There's metal. There's plastic. There's plastic infused with wood. There's plastic infused with like carbon fiber. So you, based on what you want to print or how thick it needs to be. Yeah, oh, I missed one point. And personalizations. I mean, like we saw in Industry 5.0, one of the things is customizations and delivering it to an individual rather than a whole group of people. So it's additive manufacturing brings in 5.0 brings that personalization aspect to it. So like I just want to highlight the different 3D printing types. I will not go into all of them in detail because it's quite overwhelming. So the one 3D printer that I will look at is the FDM. It's like it says, it's deposition modeling. So you start layer by layer and you deposit and you build a model. And I want to show you like a little demo because I have my 3D printer right here. So I'm trying to build a turbine. I'm trying to print a turbine. So I built a little blade, like a compressor blade on it. So you see how small the thing is, and it's printed that. And this is just part of it, but then the other part is this, like I have a little drawer, a little hex drawer that I printed with my machine. So this is all FDM. It goes layer by layer. If you can really see very clearly, you can see the layers. It goes from the base layer to the very top layer, and the finish is quite good. It's only me who can tell what the discrepancies are, but if you look at the whole thing, like, like this thing printed in place. Like I didn't have to do anything where, of course, now when it comes to printing items and what's passing through your slicer, how the model is, to reduce the time to print and to reduce the amount of filament that you use to print, you will orient it in such a way or model it in such a way that it doesn't take too much time or too much filament. So it's cost effective basically. So those are the things that as a printer, you like, or an operator of a printer, you need to work on. Like, what's going to be your angle of printing, or do you need little supports under it so that it's like at an angle 45 degrees and you print faster, rather than you place it like this and it needs like a whole bunch of supports to the top, and you're also wasting that much support material. So it's like a cost effective solution. Of course it has its disadvantages. uh, uh, One of them being that if you need something that is of very tight tolerances, it's still like 3D printing is still getting there. So we still need to like fine tune, or when it comes to metal 3D printing, you cannot do it on the desktop yet because of the toxicity of the materials and the environment in which it should be, or the high temperature that it requires. It's still progressing. I think there's only one metal 3D printer out there, desktop metal 3D printer, not industrial ones. The industrial ones have been there quite some time, but they're still expensive. So that's definitely going to be like in the next coming years, leading up to Industry 5.0, some advancement. And one thing I wanted to mention is when you like I was saying, when you are in commissioning, and if you could have that human machine interaction or the cobot, One of the things if the cobot could also do is like have a 3D printed part right there. So if something breaks down and you need to print a part or you need to order a part, I know we wait on site for like 2 days doing nothing, waiting for the part. And okay, once the part has arrived, now the controls engineers can really do their job. So that delay can be avoided if you have something on site and you can manufacture it on site and get it done if you don't have like a backup of items. And believe it or not, it still happens today because some parts are custom made for the company and they are not allowed to be carried by service personnel in their spare parts catalog. Like it's just like IP protected, so you cannot carry those parts with you. So just a couple more slides remaining on the additive manufacturing is based on your design requirement. You can pick what type of printer you are going to select. Like, are you going to have a flexible material, or are you going to have do you want more strength? If you want more strength, then how much is it going to be? Lower than 30 pascals, or more than 30 or 85, like you see right here. So based on the strength, you have different criterias. Based on the heat, you have different criterias. And actually, in 3D printing today, there are many materials that are being developed with high tensile strength, with high resistance, heat resistance, depending on your application, like rubber, like TPU material that's being used for any like personal applications, even not even industry level. This I'm talking about consumer level. So these materials are being used out there today to make these customizations for people. um, so then if you have a visual appearance and you need a smooth surface, what kind of material do you use? So all these materials that I have used, I have a little like phone stand here I made out of wood. And this is wood infused PLA. PLA is biodegradable plastic made out of cornstarch, so it's not plastic that we have in our like bottles. So it's not toxic because I print at home, so I don't need something that's toxic. So I pretty much print with PLA all the time. So this is a wood infused PLA, and when this came out, it was not like shiny like this. So I had to do a little bit of post processing on it, and I made like I put like varnish on the wood, a normal varnish that you would put like on any wood finished product. And some products I've had to use resin to post process it. So depends on like what visual appearance you want. Then I went ahead and I ordered this filament, which was already very shiny. So I used an FDM printer and this filament, and I didn't have to do any post processing. So I was pretty good at like what I wanted from my output, from my 3D printed part. And then I went backwards and I used whatever material I wanted to get the final product. So these are the things you need to calculate when you look at what you want to design. um, then, like I said, there are 3D printing materials like different polymers, different metals. There is sand, there's carbon fiber, there's high tensile rubber-like material, whatnot. I mean, imagination, it's all up to your imagination. There's no limit to it. Um, with that, I want to share some photos of what I have printed so far. And it's mostly been like some toys for my kid or for just like aesthetic purposes. And just trying different materials, trying different tolerances. Like when I made the puzzle piece, I was like, it didn't come out great in the first time, so then I had to reduce the tolerances and then see that my daughter can like properly fit them in place and play with it. Just like that. And then the blue filament is actually this is your PET bottle. And the thing that you can flex it right here, the PET is what makes it do it. So this is PET infused with glycol. So that's the blue filament that That's also less toxic to, actually it's non-toxic to print at home. So I wanted to try how the different filaments work with. So uh, that should do it. Thank you very much for listening to me. And I hope you guys got what you were here for from the webinar. And like I said at the beginning as well, stay safe during the COVID scenario. Wash your hands, wear your mask. I mean, how much ever we say this, it can't be enough. So I'll open it up for Q&A. I know there are only 7 minutes remaining, or I'm not sure. I was not keeping track of the time. But oh no, there are 15 minutes. So I would like to take some questions actually.
Thank you so much, ma'am, for giving us an in-depth overview of IIoT. We really liked how you described IIoT as an integration of various mechanisms. And as they say, Industry 5.0 revolution should be a revolution of values. And you proved it to us by your analysis of every aspect of Industry 4.0, be it IoT platforms, smart sensors, robotics, 3D printing, and many more. At the same time, focusing on the challenges faced. I once again thank you, ma'am, for making this webinar so informative and knowledgeable. Now we'll move on to the Q&A session where Saylee ma'am will address our queries. If the participants have any questions, they can put it in the chat box and it will be conveyed to Saylee ma'am.
Good evening, ma'am.
Yeah.
It's Chaya. Ma'am, my question is, how safe is IIoT regards to cybersecurity?
How safe? What in what terms are you trying to gauge the safety?
Like, it is safe or not in cybersecurity, because it's a like subject like I'm teaching now.
Mm-hmm.
That's why I'm asking you.
IIoT does use cybersecurity, like it does need to have cybersecurity. So without the closed coupling of the devices, you cannot have a safe transfer of information. So today, like one protocol that I have worked with in the past is the OPC UA protocol, and all the firewalls and the client server relations that use the OPC protocol, OPC DA and UA actually both are um, quite secure in terms of transferring data, and the firewalls are the ones, the settings on them that make them quite secure. So those I can't really remember the word for it, but the company is Matricon, and they make those secure systems in addition to the firewalls that do the transmission of the data um, using DA UA architecture. Right now, everybody is moving to UA, and because it's more secure and it's got more parameters that you can control when you are looking to transfer any data. But I think for today's network, there are quite a few devices that are communicating over these protocols, and they are quite secure. um, I think the condition-based monitoring from Rolls-Royce for the transducers. I mean, they have been using the OPC-DA for a long time, so I think it's in there. But I'm sure. I mean, everything has loopholes, and those need to be ironed out with the standards and the cybersecurity requirements. I hope I answer your question.
Hello, ma'am.
Yes.
Gaurav here. My question is, how can mass-producing industries will cope up with the personalized production, especially in 5.0?
For 5.0, the mass production still needs to be worked on, because one of the drawbacks of 3D printing is when it comes to mass producing any item, uh, 3D printing still lacks that speed and flexibility to do it. So uh, when you try to when you have a lot of 3D printers going at a very high speed, depending on the type of product also and the type of personalization you are doing, so you can do it for certain materials, certain items, but I think when it comes to metals, it's very difficult to achieve that with 3D printing. So I think they are working on it. Today that there is this gap is still present, but I'm sure with 5.0 they will try to bridge that gap. Because I mean, if you're docking more than 1,000 pieces, it will become difficult. But
Yeah.
I know one printer, a desktop printer, that Prusa printer. They have like 500 Prusa printers running at the same time. They are based out of Prague or Czech Republic, and they do quite a good job at mass producing items actually. And all of these devices, now you talk about a smart system or a smart factory, all of these devices are remotely monitored. I think they have their own system, or they use a Raspberry Pi on each printer, and then it communicates, and they know which printer is in maintenance or which needs to go in maintenance, or which filament has run out. So they do a remote monitoring of that as well. So I think it's going in that direction, but it's not there yet.
Thank you.
That was a very good question actually. I missed out on that point.
Thank you.
Hello, ma'am. It's
Yes.
Unnati. Does IIoT have any drawback?
Yeah, IIoT does have drawbacks. So that's what I when I went to 5.0, I did mention those drawbacks. I think I can go back to that slide and we can look at it. So yeah, the drawbacks that need to be filled in are basically listed here. Is like the device security. I mean, it still needs to be a little bit more secure. Um, the legacy equipment needs to be changed, and that can be very challenging because when you are running a plant, or when you are running a motor downhole, you don't want to stop all operations in when there is no scheduled maintenance and go in and change it. So those kind of issues will come in, and of course there is no information on what kind of skills you need yet. So those will be rolling out slowly. um, when I think for IoT, not IIoT, IoT and AI related stuff. I know Google has taken that initiative to make coding free for students, and they have given that platform to quite a few people out there. I mean, pretty much everybody can go in and learn how to code because that's going to be your base. I mean, whether you are mechanical engineers or instrumentation engineers, you need to know how to write software, at least the basics of it. So that's going to be one skill set that you're going to have to learn.
Thank you, ma'am.
Yeah, no problem.
Ma'am, I wanted to ask, how does the 3D printer knows what it is supposed to print? Like how do we give it the input?
So I have this little uh, SD card, and I put my G code file on it. And like I said, the 3D printer, there's a slicing software. Slicing is basically, in literal terms, what slicing is. Like you slice it. So you take a solid block, and what would happen if you slice it, right? So you tell the printer, okay, go slice by slice and print it. So the slicing software converts the model, the 3D model, into the printer understandable language. So it's very important though to know those parameters, what your base thickness is. So let me explain. So let's see if I want to print this. Um, or maybe let's see. This is a fan that I printed for. I mean I printed parts for my 3D printer for it to be more robust. So this is a fan that I printed. Now I printed this. This didn't turn out well. There are some issues in this. So if I were to print it like this, like base flat, I know I need supports here. How is it going to like print the top of it, right? So there's an overhang here, and this is where it has got messed up. Like if you can see, I don't know if it's like too clear, but what I told my printer is go layer by layer, layer by layer, and print it. So I printed this at an angle actually, and so this part didn't need supports, but I needed little supports over here. So it goes, I just put this through the slicer, and I said maintain my base thickness to be like 0.4 millimeters, and my height or my shell thickness or the outside thickness, like this, the outside thickness to be like 1.2 millimeters. So it's a little thicker than what I expected to be. I expected it in the first place, and then it printed this out pretty well. So I need to know those, the shell thickness, the base thickness, the height of the entire product, or these are all aspects you learn when you hold your product and you see, okay, this doesn't feel right. I think it needs, I printed a vase and I think it needs to be a little bit thicker so it can hold the water. I did a leak test on one of my vases and I said, okay, it's leaking a little. So maybe I need to make my base a little bit stronger. So when the base prints and the top prints on it, like layer by layer, they both are fused properly so that there's no leak over there. So you need to know what to tell your printer slicer to do. And then that's what gets sent to the printer. And the printer is doing an XYZ coordinates basically. So it's saying move X, move Y, move Z, like everything's moving in the X, Y, Z. There are also circular printers that do polar coordinates. And then there are these rectangular printers that do X, Y, Z coordinates. And that's how you build from bottom up.
All right, ma'am. Thank you so much.
No problem. I hope I answered it.
Hello, ma'am.
Ma'am,
Yes.
Hello, ma'am.
Yeah, go
Ma'am, is
ahead.
there any testing parameters, like as you said, you printed a fan, but it did not go well, right? So on a larger aspect, on an industrial aspect, is there any particular testing parameters or something like that? I mean, to check whether the end product would be correct or not.
Yeah, of course there are. Like even with every control system, when you develop it, there is a test plan. There are requirements that you check it against, and then there are these VNVs or verifications and validations you need to run, and that's pretty much applicable to every system. Either it's a physical product, or it's a software, or it's a controls. I mean, any software, any control system you write, it's applicable to it. There will be requirements. You need to adhere to those requirements. Now, those requirements might come from you, or they might come from test, or they might come from some other division who's running the system.
Okay, there's no standard param.
Sorry?
Standard. Is there any standard parameter or standard check procedure for it, or is it given by the user or the person who's coding for it?
It definitely is given by the person who has coded it, if it's a software, person who has manufactured it. But yeah, I mean, the person who actually wants to use it. So if somebody requests me for a vase and I give them a vase that's not what they requested, then they're going to come back and say, look, this is not what I requested. So yeah, they have the requirements, and it's custom. So it's not like there are a set of requirements and you can apply it to all solutions. It's different for every product. Now this here, it's just a demo purpose compressor, right? So I don't really care what the length of it is, what the breadth. It's just a demo, so I can keep it there. But if I were to integrate this with a whole Arduino project, trying to drive something, then I need to make sure that, okay, the blades are correct. But that's all coming from me because I am looking at that system. Um, but yeah, they are different. They're different for every product you make or every item you work with.
Okay, thank you, ma'am. And one small question: that what inspired you actually to get into this field? I mean, like, from being an instrumentation engineer, how did you come up to this field?
Come up to
Like what inspired exactly? Yes, IIoT or to an R&D control engineer as you specified.
Control systems was always my thing. You should ask Sadala, sir. I think, yeah, when I first learned about PNIDs and PI controllers and stuff, I think that's what's always connected with me. And when I did my masters, I actually did my thesis, and I did control systems in my thesis. That's why I'm telling you, like, one of my advisors was mechanical and the other was electrical in my masters. So you need to know control systems, whether you are electrical, whether you are mechanical, whether you are instrumentation. I mean, um, there's no limit to control systems, basically. And that's when, like, because my mind is now trained in that way after so many years of working with different systems, I have I have that drive to, learn new things. And I looked at IIoT when I was working with GE on the digital marine project, and it really, like, it was out of my comfort zone, because all these protocols and communications were not my strongest suit, I must tell you that. But I had to know it in order to know what my control system was doing, because only knowing my control system is not going to really get anywhere if it's not value adding. So I looked at that. I set up the offshore servers myself. I mean, if you are from this generation, with all the technology access you have on your hand and all the AI that's rolling in, you can really figure out anything. I mean, it's called the millennial. You guys are called the millennials. I think there's another term for it after millennials. Um, the generation X or Z, something like that. Like, you guys can figure anything out. Like, if you have a drive for it, and if you are given a computer and a laptop or any phone to figure out anything, you can figure it out. So that's what I did for IIoT. And once I got a hang of it, I had a couple colleagues who were, let's say, a little, like, geeky or nerdy in terms of 3D printing and new technology. And I used to, like, see, like, how much, like, they're curious about um, systems. And my first job was R&D engineer, and it was product related. So my biggest happiness is when I can see my product out there in the field. It's like, oh my God, I can touch and feel my product. This is what I worked on. Like, I wrote the control system for it, and it's actually working. Like, we are out in the field trying to commission it and get all the parameters readed properly, and it was a great feeling. So I think that's what motivated me to get into 3D printing, is I can, like, hold my product. Like, I mean, it's printed. I mean, the first, I've seen a 3D printer many times, but the first time I printed things on my printer, I was just like, oh my God, this is amazing. Like, I can touch and feel my products. And now my daughter, she's 3 years old, she even knows, like, if I have something different that I don't get in the store, she will look at it and she will say, she will tell everyone, my mama printed this on her printer. So it's like a different feeling altogether. I will tell you that. I think that's what keeps me going even with it. I mean, based on what workload I have, for the past 3-4 months, I haven't been able to print because I'm too busy trying to get my projects out. So yeah, it's been sitting there, but after that, I know I will pick it up.
Thank you, ma'am.
No problem.
Hi, Saylee. This is Lalit. I'm from Siemens, Singapore. It was
Hi,
hi. It was a pleasure listening to the interesting perspective that you shared.
I'm
Uh,
glad.
I'll just add a little bit to the last question that was asked by one of the students.
Mm-hmm.
Uh, it's IIoT is more of an evolution. Yeah,
Correct.
Right from industry 1 to industry 2, industry 3.0, and now we are at 4.
Yeah.
So the entire thing has been evolved, and the beauty of industry 4.0 is the IIoT integration, which has come up very strongly.
Yes.
And we as automation engineers, instrumentation and automation engineers, we come from the OT side of it. Our storyline starts from the OT side, and that's where Saylee, you rightly mentioned with respect to the basics. A strong basics in measurement and controls brings us that edge, which makes
Yeah.
us the SMEs, and of course, learning the IT scope of it. There is no choice, there is no way out, but we have to.
Yeah.
And to what extent we have to go into these learnings is up to each of us. I mean,
Yeah.
if you love coding, then there is no stopping. I mean, you can go to the depth of it, but if you don't like coding, but at least knowing the architecture, knowing the basics, you can still, be part of this industry 4.0 revolution. So just wanted to add some more inputs to whatever things that you said. And I come from the process side, and the perspective that you gave was more on the discrete side of it. I really enjoyed it. Thanks.
I'm really glad, and I am happy you made those points. It is definitely something worth noting. Making an effort is like an individual item. Nobody can ask you like make this effort or make that effort, definitely. But when it comes to a control systems perspective, you don't get scared of coding. I mean, it's not like rocket science. You need to understand what your system is reacting, code, like putting your system into code is just, it's just logistics. So it's not difficult if you're a control systems engineer to put everything in writing. Basically, what are you coding is you're coding your logic. What is going where, what signal is coming from where, how are you controlling it. I have mechanical engineers in my team who code, who run simulations, who are pretty good at it. I mean, they do it like they studied coding. But that's the future, and you cannot avoid it. You don't have to be like the web developer and the coder in that sense. You need to know MATLAB. If you can do MATLAB, if you can do those simulations, I think you can achieve any form of coding. Like I've done C++, like right now I'm doing Allen Bradley coding and Siemens TIA coding. It's not difficult to pick up. Actually, you don't have to be like a topper, and you don't have to be like, oh, I know everything and I can figure it. No, it's not rocket science. You can easily look at things. It's English. You can easily read it and you can say, okay, this is not working right. Use a little bit common sense and you will be set. You don't have to worry about it. I know there's a little stigma behind coding, and I was one of them. I was like, oh my god, I need to code, and no, it's not difficult at all.
Yeah, in fact, my experience right now says that we have a big shortage of guys who can do analytics, especially from the engineering course point of view. The analytics part, the statistical modeling part of it, that's never a topic of interest, but this is a topic what industry needs today. I mean, it's a very integral part of
Yeah.
industry 4.0, and that is something that I would like to share with the students as well. Modeling is a big thing.
Lalit, can I request you to turn on your video?
Okay. Yeah, it's 11 o'clock for me.
Yeah.
Good to see you.
Yeah. Can you see me?
Yeah.
Yeah.
Yes.
Okay. That's it. I just wanted to make this point as well.
Yeah. Yeah, I agree with you. It's important. Like for me, one of the things I did when I was in my first job was, I know I was in control systems, but I knew that the world was going in a direction of IoT, and I was not doing anything directly related to it. So I was trying to think, 5 years down the line, am I going to become obsolete? Like, what are we doing with just on, like you said, on the OT side of it? So then I went and I looked at, I mean, of course, my LinkedIn profile was there. So I keep getting these job requests and stuff. And even though I don't want to, I look at the profile at least and I see what they are asking for. So what's out there in the market, you need to know what your value is out there in the market. So I used to like, look at those job descriptions, and I figured out, okay, things are not like the same, and I don't know what this machine learning is. I don't know what this AI is. So I took a course on Google, for machine learning. Actually, I took a course on Coursera. Coursera is a pretty good platform to do any kind of courses, to get certifications, I mean, with or without certification. So I did that machine learning course. I maybe understood only like 50-60% of it based on my background in engineering. I didn't understand a whole lot, like, because I was on the instrumentation side of it, and it's a lot of the system stuff I understood, but the IT stuff I didn't understand. So I at least got my basics out of it. And I'm trying to be realistic here, because you can't really expect, like, okay, I have so many years of experience in the industry, but I'm not a perfectionist at everything, um, in the sense of, like, I don't have all the knowledge. You need to realize your own potential, and you need to realize how far you can take it. And mistakes are okay, learnings are okay. I mean, it's high time we start accepting what things are in reality. So I did that machine learning course, and it helped me a lot, in terms of navigating. Like, I knew what was happening out there. I knew what was coming, and I was prepared to talk about it if I needed to have a discussion with anybody when I went to these job fairs or conferences. The best way to learn anything is go to conferences. Like, even if you have nothing to value add at that moment, you will come back with a lot of things in your head, and it's an important experience you should have. Even if you don't write a technical paper, go to conferences, go to seminars, go to webinars. It's a great way of knowing the environment, the present scenario, like where you currently are. If you don't listen to your teachers, at least go to the conferences.
I mean, you touched upon the perfect points. I was about to tell the students that what the market needs is available on LinkedIn, and you
You
nailed
did.
it.
You
I
did.
mean, those job descriptions talk about what the industry needs,
Yeah.
and especially at this time, no, of COVID, a lot of students reach out to me because the morale is down, which is obvious, which is natural.
Yeah.
You don't have to worry about it. But as Saylee rightly mentioned, no, she did it on Coursera. I recently did a course on database management. See, Industry 4.0, the entire story revolves around data, where you have a lot of products and solutions which has to be stitched together. There is no
Yeah.
one solution which will, it's like one IIoT solution. There's nothing like that. So you have to take data, you have to store data, and then you have to pass on the data. So I took up database management very recently. I mean, so that is what is all about evolution. So you will have to learn these IT topics. I mean, there's no way out. And refer to the job description, because each one of us are unique. We have our
Yeah.
own strengths, what Saylee mentioned very rightly. Your success will depend majorly on you playing on your strength,
Yeah.
because that's the only thing that can keep you motivated, and that can give you the edge in the global market. So perfect
Yeah,
point.
knowing yourself is very important when it
Yeah,
comes. It's not a rut, like after you graduate, you need to find this job and you need to do this or
absolutely.
do that. I mean, the more you can try to get out of the box, the more you can achieve in your life, the more you can realize your own potential. So learn your core principles and then try to see where you stand. I mean, LinkedIn is a great resource. I know they give their own courses as well. There's
Yeah,
Coursera, but one piece of advice I'll give is if you can try to pick a course that's outside your comfort zone or that's outside your direct line of education, you can really reach a lot of places. uh,
absolutely.
Try to do that on a periodical basis. I mean, try to do it every 6 months. Maybe you want one course, it will stick in your head because you decided you wanted to do it. I mean, how many times I tell my daughter to do something and she will not do it? Our parents tell us to do something, we don't do it. It's only when we decide we want to do something, we do it. So it's this basic, and like Lalit said, it's an integration of a lot of these technologies that I've mentioned earlier in my webinar. It's stitching these different technologies together to give a customized solution to the final client or the customer. So that is IIoT, and it's flexible, it's agile. The process is very agile of IIoT.
Yeah. And this point that you mentioned on conferences and seminars, very interesting. I mean, I had used that in the right from the college days, and my only suggestion would be ISA. Right from the college till now, I am an ISA member, and uh, RJIT has a ISA chapter. So make use of this particular platform. It's very strong. It's a global platform. It's an American organization, and then it has recognition. So
And I
that's
want
also a good
to
point.
I want to share a little bit that I've been with Siemens for only a year. I moved to Canada in January 2018, actually, 19. And because of the market in the US was not that great, and the dependency on a work visa was really painful. So we decided that we just want to come here, and we literally packed our bags and we came here without a job. And I'm not. It's not. Only after we like met people here or got our new jobs was when we realized what we had actually done, because people came to us and they said, oh my god, like how did you come here without a job, like how did you just, I said. And I think both me and my husband, who's also an alumni of RJIT, I mean, we don't really we realize our value of working in the industry, and knowing that okay, I think we can crack it, we can get what we need. And if we don't, we'll try to find out, like, how many years of struggle will there be, how many years of um, not knowing will there be. Try to do something on your own, try to be something on your own, be fearless. That's what this is about, that if you can adapt. And that's why I said when I started this whole webinar series that I have looked on YouTube that RJIT is doing is like respectful for me, because as soon as the pandemic started in March, you guys have taken this digital thing to a different level, and I'm really happy and excited that the whole college, the faculty, everybody is getting their gears together and trying to get the students what they need. I'm really happy for that.
Yeah, in fact, one of the faculty member was my faculty as well, Dipali madam. I have been her student as well. So she did invite me to RJIT a couple of times. It was my pleasure to be there and interact with the students.
Yeah. Any more questions? I guess not. Yeah, and don't be afraid to ask questions. Okay, there are no stupid questions, there are no stupid answers. It's just normal, it's life.
Thank you, Lalit sir, for your guidance as well. Thank you, ma'am, for addressing our queries and also for the demonstration and brief overview of 3D printing. It was very interesting. Now I request Yash Mistry to extend a vote of thanks.
Krish, can we ask
Yes.
Saylee to stop presenting? Because,
Yes, I can do that.
yeah.
Good evening, everyone. I am Yash Mistry, Assistant Cultural Secretary of ISA RGIT Student Section. And on behalf of the Instrumentation Department of Rajiv Gandhi Institute of Technology, the volunteers extend a very hearty vote of thanks to our today's speaker, our Instrumentation Department alumnus, Ms. Saylee Panchbhai, who took out valuable time off her busy schedule. I must mention our deep sense of appreciation to Ms. Janvi Sail, President of ISA RGIT Student Chapter, for her work. I also wish to express my gratitude to our management and Honorable Principal Dr. Sanjay Bokade sir and Vice Principal Dr. Sanjay Deshmukh sir for providing encouragement and support. I am very grateful to all our professors for giving us an opportunity to organize this event. Special thanks to our HOD Dr. S.P. Sadala and Professor N.S. Chame for helping us grant permission for this webinar speak series. Also, I would like to extend a special thanks to Professor Dipali Joshi Jain, who is our ISA RGIT faculty advisor, for always inspiring and guiding us. I especially like the way you have touched upon the basics of IIoT and all the real life examples and how it is used in real world applications. Thank you for sharing your journey from a fresher to becoming an R&D controls engineer. The most important fact that you cleared about the connection of instrumentation with IIoT and how it helped you in your career, as no program can become successful with a single person. So I extend my big thanks to our ISA-RGIT team and instrumentation department for their continued support and all our volunteers as well. Thank you everyone for making this event successful with your contribution. Thank you Saylee ma'am once again, and thank you Lalit sir for your inputs too. This webinar was enjoyable yet very informative. I'm sure you have ignited a spark of curiosity in our mind regarding industrial Internet of Things and 3D printing, and we would definitely gain more knowledge about it. Thank you. Now I would like to hand it over to Shreesh.
Thank you, Yash. On that note, we would like to end our webinar. But before that, if you want to know more about the upcoming events, then you can follow us on our social media handles. The links will be provided in the chat box. Thank you everyone for joining us. We are hopeful that this webinar will surely be helpful for us and will explore more opportunities in IoT and 3D printing. Thank you.
Thank you, everyone.
Ma'am, I think we should stop streaming now.
Yeah, I'm